This is a how-to session, a hands-on session. My hands will be on demos, that is. But it's also more than that. It's also guidance, right? I mean, just because you can do something doesn't mean you should. And my clock actually does read 1 minute to start, so I'm not going to dive in just yet. I'll just get the pleasantries out of the way. These 45-minute sessions are quite challenging. I normally am used to, and most speakers are used to 75-minute sessions. Occasionally we have to trim them down to 60 minutes, which is doable if you talk really fast. But when it comes down to 45, you have to kind of be a little creative. So this session is focused purely on JSON, but in terms of how-to and the demos. But in a broader sense, we'll actually also be talking a little bit about XML. And we'll also be talking about the guidance as to when it's wise and when it's not to use these capabilities. My name is Leonard Lobel. En I come from New York. Ik spreek een beetje Nederlands, niet genoeg om een sessie te geven, so we'll just do this in English. I have written several books on SQL. Nowadays I'm doing Pluralsight courses, so if you like what you hear today, there's a lot more of it in my books and my Pluralsight courses. Okay, that's enough about me. And my contact info is here, of course. If you want to reach out, I would love to hear from you. And because keep the doors open only on that one side and not on that other side, it's right thinner, much thinner over there with lots of free seats. So just kind of make your way over and don't be shy. All right. I'm pretty sure you have access to all the content from this conference. But I always, as a matter of routine, will zip up my slides and code and throw it up on my OneDrive at this bit.ly link. So it's TechDays 2017_JSON, all lowercase. And there's not a lot of code. It's just a bunch of scripts, right? Well, we're going to first talk about built-in JSON support, and it's not really actually called native JSON support, as we would call XML, native XML support in SQL Server 2005 forward. So who's worked with XML in SQL Server before? Lots of people. Great. We all know. We all understand what it is. I probably don't even have to go too far to explain what it is to balance between sticking with the normalized, normal way of doing things and putting things in tables and columns and so on, versus let's say perhaps defining a column as an XML blob, you know. So that's in terms of guidance, there's really no difference between JSON and XML. It's just that today, you know, JSON is the new XML. Like JSON is the new kid on the block. But conceptually, it's the same. Like, do you store or retrieve or transmit information, data in a tabular form or in a kind of document hierarchically structured form, whether that would be XML or JSON. And plenty of seats on this side, guys. So just come on over to the left, my left, that is. So it's conceptually similar to XML. However, there are some very unique differences. For instance, there's no new JSON data type, right? And this is the lessons learned. So if you've ever worked with the XML data type from even before it was introduced, before there was an XML data type and you were storing XML in the database, you would store it in a varchar max, or before that there was text, right? Then when the XML data type was introduced, you had to migrate your data over, right? You had to create a new XML column and bring it over. And there was a migration process involved there. And as a result, therefore, they learned from that. So if you've been storing JSON in your database prior to SQL Server 2016, you don't have any migration work to do. You can just continue using that column. So how do you enforce well-formedness? We'll get there. But understand there is no native JSON data type, okay? So another lesson learned was the fact that if you look at many of the compelling new features, not all only new in 2016, but new in 2012 and so on, many of them have, like, you know, this list of limitations. And when you look at the list of limitations, there's always these data types that aren't supported with that feature. And XML is notoriously among them. Well, the SQL CL, all of the CLR types are notoriously among those. The hierarchy ID type, the spatial types. These are types that generally don't work with many, many features. All right, so this was another reason why Microsoft made a decision based on lessons learned from the past not to create a new native type. There's nothing that doesn't work with a varchar. Everything works with a varchar. So if we just continue storing our JSON in a varchar, then there's no cross-compatibility problems at all with any new features or old. That's just a side point. I want to. You'll see that in the demos that there aren't actually JSON indexes, but there are ways that you can index commonly queried JSON paths, and we'll get there in a moment. But this is essentially the workflow slide. So here's where the debate rages, right? And you have extremes on both sides, and as usual, when there are extremes on both sides, the reality and the truth lies somewhere in the middle, right? So you have purists who say that, XML or JSON, whatever you want to call it, this hierarchical format of data is great as a mechanism for passing data across the network, right? But in terms of persistence, you should never store your data as JSON, right? You store it in normalized tables. You define your tables. And then you have folks in the other extreme that will say, no, you know something, with XML and XPath and XQuery and XThis and all of the technologies around and support around XML, and today JSON, I can do everything without the relational database who even needs SQL Server at all. And so reality is somewhere in the middle. There are actually quite a number of times where it does make sense to store the data as JSON in the database. But you don't have to do it that way if you don't want to. There's a lot of gray areas in between, and there's a lot of flexibility to do whatever it is you want to do. For example, if you have this tabular set here, and this is how data is stored in your database, and you want to expose it as JSON, all you need to do is tack for JSON on to the end of an otherwise normal query. And you will get a JSON array representing the results set, with each row represented as a JSON object. Right? So the schema just gets inferred, and there you have your JSON. And if on the other hand, you need to consume such JSON, you can use JSON value and JSON query to actually drill into that JSON and extract any property or property value or subset of JSON that you need or want to, and you can use the isJSON function to actually check for well-formedness. Now, if you're just getting one of these objects and you need to pluck out values and you need to pluck out values, then you can use these functions. But if you get a large blob of JSON that you need to shred, let's say this array that you want to shred into 2 rows because there are 2 elements in the array, you want 2 rows plucked out of that JSON, then you can use the openJSON table valued function, and we're going to see all of these in live demos. And then there are hybrid scenarios as well. You can return a tabular result set with a little bit of JSON embedded within it. It's not either or. You don't have to store JSON in the database if you don't need to or want to, if it doesn't make sense. But you can, or you can expose it, and you can manipulate it in any way. And it's simple to just append for JSON auto or for JSON path. And let's just refer to these slides as reference slides that you can review after the demo, since I'm trying to keep this session down to 45 minutes. It's pretty simple and straightforward, as you'll see. I'll flip on over to Management Studio and use good old AdventureWorks 2016 CTP3, which, by the way, is the absolute final version of this sample database. Now there's a, what do they call it? I think I might even have it. Wide World Importer or something like that. No, I'm in Visual Studio. So actually, notice I am in Visual Studio, and in a moment you'll see why I'm not in Management Studio. First of all, in SSDT, in Visual Studio, you can do anything you can do in Management Studio, include running like script in this query window. So let's start off with a simple relational query. This from clause is joining 2 tables. And if you look at the where clause, I'm pulling 3 customers. So I execute this query, and what do I get? I get 9 rows. Why do I get 9 rows when I'm only querying 3 customers? Well, that's the nature of joins, of course. It happens to be that each of these 3 customers has 3 orders. So by the nature of the cross product, when you join, I get 9 rows. Now, that's to demonstrate how wasteful traditional joins can be. Because we all understand that normally we'll have many more columns and many more tables, and with each descending level of depth within the graph of our entity, we are just duplicating data, and which is why DBAs hate entity framework with a passion, because C# developers just they say dot include, dot include, dot include in their C# code, and you see the query that comes out, and you see the results that comes across the network as a result. It's horrific. Right? There's got to be a more efficient way of doing this, right? So I might need, this might be the way it's represented by a join, but it's not necessarily the most efficient. And it might be the most efficient to store our data this way, but not necessarily the most efficient way to transfer our data this way or transmit our data across the wire using TDS, right? Which is the native tabular data stream that's coming out of SQL Server query results. Well, so what we're going to do is we're going to take the exact same query. I've not modified it in any way. I've just appended for JSON auto to it, and I'll execute the query, and now I get JSON. Now, again, there's no native JSON data type. So one downside, if you've worked with XML before, you know that in SSMS there's really good support for clicking on that XML, whether it's a single blob of XML or if it's a result set that has a piece of XML in it, you can click it on a hyperlink, and it's very easy to read. It's not that way with JSON. That's just kind of the price we're paying for the fact that it is really just varchar. So the tools are trying to be a little smart, and Visual Studio is a little smarter than SSMS in this regard, as you'll see. So I get a hyperlink here because the entire result set is coming back as JSON. Visual Studio lets me click on it. When I click on the result set, it's not much better because it's just kind of strewn across, but every web developer in this room knows Control-K, Control-D will give me that, nicely formatted hierarchical view. And if I collapse this down, it's clear to see that what I've got here is an array with 3 items in it. Not 9, 3. And the parent information is repeated once, not once for each child. And the property names are named after the columns, and the child array properties are named after the table that you're joining on. And this is why I'm doing this in Visual Studio. You can't kind of get this better view of the JSON any other way. So if I move on to some other examples, and I must keep track of the time, all right? We are only about 10 minutes in, so we're good. You can start tweaking this thing. So if I append root, I get, instead of that one array that represents the results, I get back an object, right? It starts with a curly brace, not with a square bracket. So because I'm saying I want my result set to come back as a property of a single root, as the value of a single root property, which is named after the table, which itself has that bounded result set of 3 customers, each of which has 3 orders. I'm going to skip the ones that are a little less interesting. Here we go. This one's a little bit more interesting. This is the hybrid result set. So this is often a very nice compromise that can work very well in terms of solving the problem of a more efficient result set when you don't want to duplicate parent information on each joined child. And one way to do that is to return just a hunk of JSON or XML, right? Conceptually the same thing, right, in this regard. And do it that way, but you might not be prepared to just get back a big blob of JSON. You might still want your tabular result set. You might want some sort of hybrid compromise where I'll say, okay, I don't want to return 9 rows. I only have 3 customers. I want to return 3 rows. I don't want to return a hunk of JSON. I want to return 3 rows. There's 3 customers. I want to return 3 rows in a tabular result set. But in terms of the child data of that row, I want to package that up inside of a JSON column, right? Returning that result set. So I'm not storing my data in JSON in any way, but I'm really kind of optimizing my result set. I'm not going full-blown JSON on the result set. You're getting your tabular result set. Oh, you want the detail? Well, there's a little chunk of JSON in one of those columns, which, I mean, how much effort in .NET is it, or any platform, I should say, to deserialize that? I mean, certainly trivial. So that's a wonderful compromise and a wonderful technique, and it can speed up your applications dramatically. I know it speeds mine up dramatically. I work with a very deep entity. It's called the X12 document space in the healthcare industry, and it's very, very deep. And I've got a single auto-generated. So first I get the metadata from the root object and discover all the descendants via the primary and foreign keys, and dynamically generate a select statement that brings the entire hierarchy out at once. And that serializes right into an entity framework object, right? At that point, I can attach to the context. So this is not like this approach can integrate very nicely into current patterns. So let's see how this works. It's an ordinary select where I've got a customer ID column and an account number column, but in terms of orders, there's this nested select which has the for JSON auto. And I'm also using root like you saw before. And because I don't want the root property to be named after the table order headers, I want it to be named sales orders. I'm also supplying that parameter. But again, just 3 customers. And so I'm getting back just 3 rows. And this is where things do break down a little bit even in Visual Studio. This is not something I can click on as a hyperlink and format neatly. But we all understand that those are each one of those JSON blobs is the 3 orders belonging to each one of those customers. Yes? Yes, so perhaps I've not been clear, and if I've been misleading, I apologize for that. This can certainly be, everything I'm doing here can be done in Management Studio. You do not need to be using Visual Studio at all for this. However, you will not be able to format your JSON results neatly when you're viewing them, and making it harder for me to demo this, and that's just purely because of the fact that, again, it's not a native data type. And here, even in this case, once you're returning it as an embedded column, you can't even click on it here. So auto means automatically generate this JSON. Actually, it automatically flattens JSON as well. What we want to look at next is for JSON path. For JSON path gives us the ability to kind of customize the shape as desired when we need to customize the shape or want to. So we just alias our columns, and we use the dotted notation to indicate that we want, for example, all of these to be nested under contact name, right? And gender and marital status under personal info. Now I've kind of shaped it just the way I want by using for JSON path. So this is the kind of thing that I would auto-generate. So it's hard to read and maybe a little hard to write, but if you first of all, if it's a relatively small demo or a small example, it's manageable. If it's a proof of concept, that's one thing. And if it's very large, like I said, it's not that hard to crawl the metadata of the information schema views within SQL Server to discover from a given root table what all the descendants are and build out and auto-generate a select statement like this in a SQL stored procedure. And if you combine that with Temporal, have you heard of the Temporal feature? Raise your hands if you've heard of the Temporal feature. Okay, good. It has nothing to do with this, but it lets you travel back in time at the table level. For any table that's a temporal table, you can go back in time. So I've combined. If you combine the two, it's very powerful. So I have one stored procedure that will let you, you pass in one ID of the root entity, you get back the full-blown entity, right? And as JSON or as XML, so it's very, very performant, right? But you can also pass in a parameter, say, at what point in time you want the data, and it gets tagged onto each select, right, automatically. But if we look at this select, this is the innermost descendant, so it's the easiest one to read because this select matches up with this from. This select matches up with this from. I've made it a little easier because of the way I've indented things to see that, but it would be harder to see that if I didn't indent it. And then, of course, the further out you get, the harder it is to see that this select matches up with this from, but that's exactly the way it works. Right? And when you build it up that way and you combine it with for XML path, yeah. And for JSON path, because it's really, again, the same thing. Oops. Control K, Control D. That's the thing. That's what I just did now here. Man, that's the thing that you can't do in Management Studio. Showing it like this. That's the only thing that you cannot do in Management Studio. Today, anyhow. Right. So it's quite customized and optimized for transfer across the wire. Then it can be serialized, or it could be like sent directly out as part of a web API, whatever. All right. That's it, generating JSON. What about querying JSON and manipulating JSON? Well, we have the isJSON function that will actually let you pass in a string, and it will tell you if it is well-formed JSON. If you have unbalanced braces or unbalanced square brackets and things like that where it can't be parsed. So that's the answer to the question, which might have been on your mind. How can you ensure well-formedness in your tables when you're storing JSON? And the answer is that you use a check constraint. And if you're not sure what a check constraint is, you need to be sure what a check constraint is. Okay. A check constraint is you might think of it like a trigger, but it's not a trigger. So instead of having a trigger, you actually put on the table, you say some expression, and that is JSON passing in that column must be true. Otherwise, you cannot store invalid JSON in that column. SQL Server will reject it. JSON Query and JSON Value are both very similar. They both let you drill into a piece of JSON. The only difference between the two is whether you are drilling into a scalar value, that at that point all you have is an int or a string or a date, or whether it is some subset of still more complex JSON, either an array or another object. And it's super simple dotted notation. I mean, the $ represents the root, and you can index using square brackets and drill down using dots, and it's as simple as that. And that's just a review slide. Let's actually see it in action. How do we query JSON? All right. So I'll go ahead and use my database. And I'm storing, this is an nvarchar max. So it can be any string type, varchar, nvarchar, text, and so on. And I'm storing in here some JSON. And then I'm executing the select isJSON function, and it's returning 0. Why is it returning 0? Because on the customer ID property here, it's missing the closing quote. So all I have to do is fix that by adding the quote, and now when I run the very same code, isJSON will return 1 for true. Knowing that, we can create that check constraint. There's that check constraint which I was talking about. You can put any expression in there. If you do it carefully, you can even refer to a user-defined function that can do data access, to check things properly without resorting to triggers. You should only really resort to triggers as an absolute must, and if you can avoid them, you should. So this is like a trigger, guaranteeing on every insert or update that SQL Server will reject an attempt to store malformed JSON in this orders.doc column, whose data type is just an ordinary string. And if you don't supply any value, you're going to get an empty array. So if I create that table, if I hadn't already, okay, and this is the very same bad JSON. You'll notice on line 197 here, I'm missing that closing quote. So I can store it into the variable. I mean, that works fine, right? Because it's just a string. But as soon as I attempt to insert that, it fails, and it names the check constraint as the reason. So that's how you make sure that you have a good JSON. So if I just fix that again by adding the quote, perfect. It inserted my row. And if I insert a row without specifying any JSON, because the default was an empty array, that insert works too. Here's my table. You can't hyperclick link these things. It's just, to the tool, to the client, this is just a string data type. It's really hard to. It would be nice if we could annotate it for the tool's benefit. Yes, sir. 2 questions. I'm sorry, I beg your pardon. Validation? Do they qualify as now a valid JSON string, null or a string empty? That's a good question. Why don't we find out? But of course, you use up your questions. My guess is going to get false. All right, how's that? Null, null, you get null, and that's probably going to be false. Yeah, because it's not valid JSON. It has to either begin with a square bracket or an angle bracket. And the other question? One question was about the null, and one question was about the empty string. All right. I like that. All right. Let's clean up and let's get a little more useful. So going back to the guidance aspect, I mean, one of the compelling things about JSON and XML is that you don't have to maintain a schema, right? I mean, with XML, you can. XML is more powerful than JSON, to be clear, because you have XSD. You can enforce a schema if you want to. With XML, you can't, do that with JSON. It's schema-free. Schema-free, though, is actually not accurate, because every item does have a schema. It's just that every item is free to choose its own schema. That's what schema-free means. So it's very compelling to not have to maintain the schema of items, especially if they change very rapidly. It's one of the compelling reasons driving people to the NoSQL platforms like Cosmos DB and DocumentDB, if you've heard of those. So, other reasons to move to those platforms are global scale. And if you don't need global scale and planetary scale, and you're not ready to abandon SQL Server, but you'd still like to enjoy the benefit in limited amounts. If you start doing this everywhere, then it's just not good. If you just start putting JSON columns and XML columns everywhere, or every table in your data, I mean, you can imagine a table, a database where every table has a primary key, a foreign key, and an XML blob or a JSON blob. You've got a schema-free database within each entity. The entities themselves are still linked in a very traditional relational way. That's kind of interesting if you think about it. But that's really extreme, and I don't think I'd advocate that. but in gentle doses, there's really nothing wrong with it. So if I decided that in this book table I don't want to maintain the schema of all my different every different book as it changes. I can create a table and choose the book doc column to store JSON and apply that check constraint to make sure that only good JSON gets stored in there. And there's my book for IT Pro category, and there's another book in the developer category, and I'm inserting these books one at a time, and it works just fine. And now when I select from the table, there they are. I can see this one says these two are in IT Pro, and this one's in the developer category, but it's just one blob of JSON in the book doc column. So if you look at this JSON value function, like I said, the $ means the root, drill down into the property, and it's really simple to just query out. And your traditional where clause can combine normal column checks along with drilling into JSON to detect for the value or presence or absence of a property, in this case getting only the two books whose category is IT Pro. Of course, if we were frequently querying on category, we would want that column indexed. And as I was kind of alluding to earlier, there's a little bit of an awkward way of doing this compared to traditional true XML indexes. We don't have true JSON indexes. Instead, you create a computed column against the path, and you index the computed column traditionally, like so. You add a column. Using the as syntax means it's a computed column. And then you create an index on that column. It's as simple as that. If I know the schema of the data that I'm working with, which most often I do, I can start plucking out JSON. In this case, I know I stored the JSON in here, so I know that I can drill down to the category and the title, and amount is nested within price, so the double dots, using JSON value in each case. And here I'm doing the exact opposite. The exact opposite. I'm storing my data in JSON, but there would be no way for any consumer to know that based on what they get back in their results set. It's the exact. You thought of your second question? Yeah. Yes. It's. I believe the answer is yes, but let's take it offline. Okay. Yeah. So there again, you're doing the kind of really extreme opposite. So you can go to one extreme, you can go to the other extreme, you can do the hybrid. You can do what's right for you. It's not a holy war with these extreme views. Never use JSON or always use JSON. That's never, of course, the answer in our field or in general in life, I think. All right. JSON Query is quite similar to JSON Value, except if you know that what you're drilling down into doesn't give you a scalar value, you have to use JSON Query. Really, it occurs to me, these should all have casts or converts on them. Because they all come, yeah, they really should, so that the result set is better typed. But in the case of JSON Query, it's going to be JSON that you get back, right? Because the purchase size is an array, so I'm drilling down, I'm getting essentially a subset, right? Because this book is available in 2 sites, as denoted in that array, which is a subset of that snippet of JSON. Time check. I have 15 minutes, right? I think. Okay, all right. We're good here. Takes us to our last topic. OpenJSON. So that was a little bit contrived. I mean, those inserts that I just performed, I inserted. Okay. Yes. No, don't be. Strings. Yeah. Yes. Correct. Yes, that is correct. But there's no type. There's no way to infer those types from. It could, but I don't believe that it does. And we would have to test it if our sessions were 60 minutes. I would test it right here with you. In the time remaining, we're going to look at OpenJSON because, again, in the last demo, I inserted 3 rows, very convenient. However, more likely, I would get like one blob of JSON, right? And I would need to shred it, so it would be like an array of 3 books in it, and I want 1 row per element in the array. And that's when you use the OpenJSON row set function, which is a table-valued function, meaning that it returns a table and it shreds a JSON source into multiple rows. And I phrase that kind of very deliberately because depending on what you give it, it will iterate differently. If you give it an array of things, you will get back 1 row for each item in the array, even though from one item to the next it could be a scalar value or another array or an object or a null. You're going to get back 1 row per anything in that array. And there's going to be a type column that's going to tell you the type. So talking about type inference, maybe you're right about that. You'll see that it does do some type inference. If, however, you don't pass in an array, let's say you just pass in an object with not knowing its schema, which for those cases where you just have a piece of JSON, you don't know what properties there are, and you need to discover them, then you'll get 1 row for each property, and you can discover the properties. So, and finally, since in most cases we do know this schema, right? So if you do know the schema, you can make it a little easier to work with if you use the explicit schema syntax where you tell OpenJSON, here, I know the schema. So actually return a table that looks this way. Shred the JSON for me. So let's see how all of this works with a live demo before wrapping up. So here, I don't have 1 piece of JSON per book. I have 1 huge piece of JSON with 3 books in it, or 300 books in it. Now I want 300 rows, that sort of thing. Well, if I simply pass it into OpenJSON, because it's an array, I'm going to get back 3 rows. Now I'm always going to get back the same 3 columns, no matter how many rows I get back, unless I'm using explicit mode, which we'll show last. And it's a way for me to kind of discover what was in this array. I passed an array of 3 items, so I got back 3 rows, and they're keyed sequentially. And then there's a column called value, and a type 5, and 5 means object. Okay? So understand as well that this is equivalent to this because OpenJSON accepts an optional parameter, which by default is the root, from which it should start shredding. So if you wanted to start shredding from some deeper point, you'll see in a later demo how we do that. But for this demo, this is exactly the same as the last one, but I can now use JSON value like you saw in the last demo, and I can extract out from that blob of JSON. Only those in the sorry, it has to be done in one go, you know. Right? I'm only getting the 2 in IT Pro, and it's sorting descending by author name, because I've got that in the order by clause. But if I pass in as that first parameter, I don't want you to start shredding at the root. I want you to first drill down into the first item in the array, which happens to be an object. Although I don't know if it is, but I've discovered already that there's an array here, so I want to discover information about the first item in the array. So I pass in that indexer, and I get 1 row per property, as you can see here, telling me that this is an object because there's a category property of type string and a price property of type number. So there's your type inference there. So I could easily have misspoken there. I had assumed, you know, that's why you should cast and convert. So there's no questions. Like, you know, don't rely on these defaults. It's always bad practice, right? So that's why, whatever the answer is, there should be a cast and a convert on that code. All right. Okay, cool. Scroll down. Right, so these are the, and of course JSON does have the types, but a very limited set. And these are the kind of values you can get back, and you can discover if things are null, if things are strings, if things are arrays. If something is an array, then you can kind of start trying to discover the schema of that array. Here's a common thing that you might encounter. So you're not embracing JSON in the sense that I don't want JSON in my database, but you're giving me JSON, right? So I need to consume it. And one easy way to do that is with open open row set. When you have a parent-child scenario where I've got a blob of JSON here, and this might be one item in a larger piece that I'm shredding with open JSON, but we're going to focus in on this one piece. This one piece has parent information. And even though it looks like this stuff is hierarchical, it's really not. This is not a nested array. It's a nested object just for grouping purposes. So there's only a first name and a last name, and these address properties for each person. But each person has multiple contacts, because that is, as you can see, an array with square brackets, and there's some mobile numbers and some work and some fax numbers for those of you still faxing. That's an old demo. And yeah, sure, plucking out the person, actually in this demo I'm just showing you the select, but in my Pluralsight course, and you can imagine it's very easy to just add the insert syntax to insert into a table. But for the header, there's already happens to be a convenient column that I can use as the ID. Otherwise, I might rely on the int identity, most likely, or heaven forbid a GUID. Hope you're not doing that anymore. But whatever the case is, some unique primary key for the parent, and I'm using that as the person ID, plucking out the various pieces of information from the header pieces, like the address lines that are nested beneath address. And in terms of the children, well, the person ID is of course going to be the foreign key. And I want 1 row for each child, so I'm using open JSON on that blob of JSON, but I'm telling SQL Server to first drill down into the contacts property before you start to shred. Let me look back up at the JSON, right? So if I just pass this into OpenJSON, I would get back 1 row for each property, a row explaining to me that ID was a number, and that name is an object, and that contacts is an array, and that's not what I want. I want you to drill down into the contacts property first, which is an array, and then start shredding where you can see I've got 4 objects and I want 4 rows, 1 per object, and that's exactly what this does. Pardon me. And just dump those into a table, and there you have it. So there's not much you can't do. You can do pretty much anything you need or want to do. Just don't do do things that make sense. Don't do things that don't make sense. How's that for guidance? Oh, good one. So in the last one here, it becomes a little tedious with, you see, for every time I'm calling, every time I'm referring to what comes out of OpenJSON, there's only key, value, and type. And value has that blob of JSON. And yeah, I can use JSON value like I did here to go into that value column. Unfortunately, it's colored in blue, but don't let that mean anything to you. That's that value column, That value column is key, value, type. So in that value column, there's the JSON, so I can use JSON value to drill in and pluck the things out. But if there's many more than just these two, and I'm doing it very frequently, this is going to be, it's not what I want. I don't want to get the JSON out. I actually want the query to also parse it out for me and give me a schema that I want. And so if I take a look at this chunk of JSON, and this will be our last demo. So we're doing pretty well. This is what we saw until now, and I'm going to get key back, key, value, and type, right? Key, value, and type. And to get at that, to extract out for all the properties that I want, it's going to be a great number of JSON value calls with these paths to these properties that are going to be very annoying. And I would just like to have those columns pulled out for me. So if you look at the very same query, but I attach the desired schema with, and I strongly type the result set that's going to come back, embedded with those JSON expressions, I get back this instead of this. And it can actually contain nested JSON. So I did that a little fast. Let me just show you what I did there. See, this one here is as JSON, because the item itself is a complex property. It has quantity, price. Like I didn't want to drill that deep. You can do that sort of thing. So, with that, I'll take any questions you might have remaining, as long as you don't try to stump me. Sure, let me take his first, and then I'll take yours. No, go ahead, sir. To enforce a JSON schema, not that I'm aware of. There's no, JSON is really schema free. There's no way to enforce a schema other than, I guess, imagine. Spec? Oh, my knowledge, there's no enforcement of any schema available. I guess you could write a trigger or a check constraint to enforce, certain pieces of schema being present, but there's. To my knowledge, there's no native solution to that. In fact, they avoid the word native. It's built-in JSON support. It's not native JSON support. Go ahead, man. Well, in terms of dealing with the results that comes out, it's just a string, and you can use traditional means. But there's, if you're looking for more than the 3 functions I showed you, there aren't. There's JSON, JSON value, JSON query, and then there's open row and there's open JSON. Yes, sir. Any plans to improve the searching beyond JSON value and JSON query? No, this is, look, this is a version 1 product. I mean, it just came out in SQL Server 2 2016. To my knowledge, there's nothing significant that was added in SQL Server 2017. Beyond graph, from a developer's perspective, and even that is half-baked. I haven't seen improvements, and I haven't seen too much critique around it. I myself use XML mostly, only because of legacy code and serializers that are out there. But in terms of guidance, they're really the same. I saw a hand go up there. Let me take the one all the way in the back. And 1, 2, 3. Okay. I also have to make sure I don't. Yeah. Okay. Good. Yeah. Yes, sir. I'm sorry. I cannot hear you. If this is about a use case of when it makes sense to use JSON, but any kind of tree structure that is just like a native tree structure. It's just a natural selection for either JSON or XML. Sometimes it makes sense to store in the database a blob of XML that is essentially the serialized representation of some object. Like, so what I do is to load and save the object, I serialize and deserialize XML, and I store it in an XML column. Right? So, for things that are just naturally lend themselves to tree structures, like you say. In terms of self-referencing, there would be no relationship between an XML value or a JSON value in one column or one in another. Let's take that one offline. I want to try to get one more question. Yes, sir? Is it also supported with entity framework? So that's an interesting question. Not natively. Again, because I made a reference to entity framework. One of the problems with entity framework is the fact that if you write a traditional link to entities query and you use .include, that it creates this massive number of joins that is a very, very bad results in very bad performance across the wire. So, but that's the native way of working with entity framework. So from that perspective, no, there's no support for this JSON functionality. However, I today am successfully using XML for this, but you could do this exact same thing with JSON. Like I said, discover the relationships, return a chunk of JSON, deserialize it into an object, attach it to your context. It could be one of your POCO classes, and once you attach it to the context, the entity framework thinks it queried the data for it. The database for that data, but it didn't. You did using this technique, and now you're using entity framework to track its changes during the lifetime of the object context. Okay, take one more? I'll take one more. Yes, sir. Oh, yeah. Well, there's lots of ways entity framework could optimize itself. Thank you, everybody. Have a great day. Really appreciate you coming.